Okay, so naming of these compounds. Now we have one carbon met, all single bond, carbon hydrogen, A and E, methane, two carbon, et, and A and E, all single bonds, so belongs to alkane family. What are these three different type of presentation? Four actually different way of presenting organic molecule. You can present organic molecule using name that represents this name methane with condensed or molecular formula, 1 carbon, 4 hydrogen. You can use the dash line this is the structure formula that shows the bond between every element in the molecule. So 1 carbon is attached to 4 hydrogen. You can use the ball and stick. So the balls and sticks. So that shows the 3D structure. And you have the space filling, which is this one. Space filling, so it doesn't show the bond length, it just shows the different nucleus, like forming bond or overlapping. Same thing for ethane and for pentane. Pentane for 5 carbon, pent, like a pentagon, so you have 5 carbon, and then this is the ball and stick, this is the space filling, and that is the condensed formula. Condensed formula doesn't show the bond between carbon-carbon or carbon-hydrogen. It kind of says how many hydrogen is attached to the first carbon, how many to the second carbon. So this is the condensed one, CH3, CH2, CH2. So it doesn't show the bond between carbon and hydrogen. And if it's 5 of them, so another CH2, and then CH3. So basically it starts with the CH3, it ends with CH3 because each carbon must be attached to 4 different bonds, must have. Expanded formula, this again shows the connection. Condensed formula, it doesn't show the connection between carbon hydrogen, but it shows the connection between carbon-carbon. A skeletal structure or line angle structure. Every line starts with a carbon, every angle contains a carbon, 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 carbon. And how many hydrogens? Enough to make 4 bonds. So first carbon has 1 bond, we have to add 3 hydrogens to make it 4. Second carbon has 2 bonds, we have to add 2 hydrogens. We don't have to add it because as organic chemists, we understand that there is 1 carbon here, so there must be 3 hydrogens. So basically these, all 3 of them are the same. Which one is faster to write? This one with no basically writing the carbon and hydrogen, so you only use the carbon. So for a compound that is 6 carbon and 12 hydrogen, you just cyclohexane, you draw this, and that means a compound. Okay. You draw, this is not a square that is coming from math, is 4 carbon and 2 hydrogen on each carbon, so it's a C4H8, and that is butane. It's actually cyclic system, so it's going to be cyclobutane. The structure A and B, these two are known as isomers. Same molecular formula, but different structural formula. If you have 1, 2, 3, 4, 5, 6, 7 carbon. So we have 7 carbon. With the 7 carbon, we have also 16 hydrogens. So if you add all the hydrogens, 16 hydrogens. In this case, you have 1, 2, 3, 4, 5, 6, and 7. 7 carbons, and if you count all the hydrogens, 16 hydrogens. So molecular formula is the same, the structural formula is different, so with respect to each other, these are called isomers. Line angle, again, 7 carbon, 16 hydrogen, 7. These two are isomers of each other. Cyclic system, if you have like this is like a branch, methyl group is coming from methane. Methane is going to change to methyl, and that is attached to cyclohexane, so it's going to be methyl group attached to cyclohexane. Methyl cyclohexane. 1, 2, 3, 4, 5 carbon is going to be pent for 5, A and E because it's an alkane. Y is the alkane because 5 carbon has 12 hydrogen. So it's the 5 carbon with 12 hydrogen is going to be pentane. And this is the line angle representation of the same molecules. Line angle representation again, you have carbon on each, assumed carbon on each, or understood. So we know we have all those carbons, and then hydrogens, we add the number of hydrogens needed. Beginning of the chain is always 3, and then in the middle you count how many bonds are there. It has already 4 bonds, so no hydrogen is needed. Here you have 2 bonds, 2 hydrogen is needed, no carbon. Here we need 3 hydrogens. Butane, and then we have isobutane. These two are isomers with respect to each other. So we have C4H10, C4H10, but the structure formula is different. 2-methylpropane means that 1, 2, 3. So main carbon chain is propane, and you have a methyl group attached to carbon number 2. So you give the location of the group, and then attached to propane is attached to carbon 2 of the propane. So 2-methylpropane. This is again a butane. Bending of the carbon, it doesn't make, as long as the connectivity is the same, bending of a carbon is not, carbon chain is not going to make a new compound. So these two are the same. These are the same. These are not different compound. They are the same compound. But if you have like a 3 carbon in a row, and then you have a carbon attached into the carbon 2, connectivity is different, then these are not the same. Okay? They are not the same. These are 2 different. But bending of the carbon chain is not going to make a new compound. 3 carbon, no branch, so it's propane. 3 carbon, so the main name is propane, but you have a chloro group on carbon number 2. You give location, and then you would give the name of the branch, then you give the main carbon chain. So we have a main carbon chain that is propane, and on carbon 2 we have chloro, so it's a 2-chloropropane. 2-methyl, methyl group on carbon number 2, main carbon chain is propane, and methyl group is on carbon number 2, so 2-methylpropane. You have 6 carbon chain here, so it's going to be hex for 6. A and E is alkane, so hexane. You have fluoro on carbon number 2, and you have a fluoro on carbon number 4, so it would be 2,4-difluoro. So branches are 2 of them. Fluoro on 2 and fluoro on 4. You combine the numbers, or separate by comma. And then you separate the number from the letter with the dash line. Instead of say 2-fluoro, 4-fluoro, you would say 2,4-difluorohexane. 1-bromo and 3-chloro. Can I write 3-chloro, 1-bromo? We use the alphabetic order. So if we have different branches, we write them in alphabetic order. So 1-bromo, and then 3-chloro, because B comes before C. And the main carbon chain is hexane. So this would be 1, 2, 3, and 4. Now we have a 2 bromo coming first, bromo, and then 1 chloro, alphabetic order. When you are numbering, you always number with the side that is going to give you lowest set of numbers. You can't say 1 and then 2 and then 3. It has to be consecutive naming. So you're numbering from the side that you would assign the smallest number set, 1, 2, 3, because if you number from this side, it's going to be 1, 2, 3, and 4. Then you would get the branch on carbon 3 and 4. So you have to number from this side because you get smaller number set. And then when you're writing the name, you have to write the branches with alphabetic order. So 2 bromo first and then 1 chloro. Then we have 4 carbon is going to be butane. So chlorobutane. Okay. Again, 1, 2, 3, 4, 5. So it's going to be 3, 3, and 4. And if you go this way, it's going to be from right to left. It's going to be 1, 2, 3, 4, and 5. So it's going to be 2 iodo and 3 bromo and 3 bromo. So it's going to be named as 1, 2, 3, 4, 5. 3, 3 dibromo, because B comes before I, and then 2 iodo and 5 carbon pentane. Okay, pentane. Groups that when you are changing to branch, it's like you drop the A and E, add il. So methane changes to methyl, ethane changes to ethyl. So if we have the main carbon chain, consecutive carbon, so I can just slide the marker when I'm numbering 1, 2, 3, 4, 5, 6. I can't go back and say 7, 8 because that's not part of the main carbon chain. Because this is going to be branched now. Because it's a 2 carbon, it used to be ethane, now it's ethyl. It's attached to carbon number 3, so it's going to be 3 ethyl, and then 6 carbon is going to be hexane. 3 ethyl, hexane. 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 carbon group here that is attached to carbon number 4. So it's going to be 4, 3 carbon propane, changing to propyl, 4 propyl octane for 8, octane for 8. So propane would change to, this one is a 2 methyl propane. So 1 methyl is a methyl branch, ethyl, propyl, and then we have isopropyl. These are just, you have to memorize how the branches are named. Ethyl heptane, 7 carbon is hept, so ethyl heptane. We have 5 carbon in the main carbon chain. Then you have 2, 2, and 4, 2, 2, 4 trimethyl pentane. And this is 3 carbon, but is attached from the second. If you go back to previous slide, you have isopropyl for this one. Isopropyl as the name. So is on carbon number 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It doesn't matter. So either way you come is 4. So it's going to be 4 isopropyl heptane location, name of the branch, and then the main carbon chain. Some reactions, they can be halogenated. That means that one halogen from group 7, if you add Cl2 to alkane in presence of heat and light, one halogen can replace the hydrogen, so you get the chloroethane in this case. So replacing of hydrogen with one chlorine is called chlorination, or general is called halogenation. Alkene, very similar to alkane, with exceptions that you do have the functional group of CC double bond, and it shows here you have a CC double bond. Ethene, so alkane changes to alkene. So propane, if it carries a double bond, is going to be propene, E. So we have E and E ending for compounds that they have CC double bond. And we have specified the CC double bond. It starts with which carbon. You don't have to say 2, 3. If you say it starts with carbon 2, is understood that it will go to 3. Because if it was between these two, you would not say 2. You would say 1 because it starts with 1. So 1 butene, 2 butene. So you give the location of the double bond. 1, 2, 3, 4. So it's on carbon 1, so it's going to be 1 butene. This is going to be 1, 2, 3, 4, 2 butene. The two same groups are on opposite sides, so this is going to be trans. Same groups are on the same side is called cis. These two compounds with respect to each other, they are isomers. They are not same compound. These are isomers. It's called geometrical isomers. The connectivity is the same, but the arrangement in a space is different. This reactions, chlorine can be added to the pi bond. So basically this is type of addition reaction, chlorination of carbon-carbon double bond. It will break the double bond. It changes to single bond, and you add 2 chlorine. There's a reaction of one of the reactions of alkene. So if you get to this one, you're going to get the CH3, CHCl, CHCl, CH2, CH3 as the product. So you're breaking one pi bond and adding Cl to one and adding Cl to the other carbon of the carbon-carbon double bond. And that would be the product that you have. Same thing, you would add the Cl and Cl. Alkyne, it is going to have CC triple bond. So ethine, Y-N-E is the family name for this. Alkyne, et means 2 carbon. So if it's 3 carbon, it's going to be propyne. So basically H and propyne. We have 3 carbon and 4 hydrogen. Is a CnH2n plus minus a 2. Minus a 2. So that's for alkyne as the family. You have to give the location that where alkyne starts. Is it the carbon 1 or 2? So in this case it's a 2, so it's going to be 2. You have 4 carbon bute, and the family name is YNE, butane. Location of the triple bond, this means there is a triple bond, and this shows the location, and bute shows that you have 4 of them. You have this 2 of them, so you have your numbering, you have to number it and then give the location to both of them. So you have you have the triple bond on carbon 1 and the double bond on carbon number 3. You can add the halogens to CC triple bond. Basically is 1 sigma and 2 pi bonds. You can break both pi bonds here, and every pi bond you break, you add 2 halogens. So you could actually make a tetra bromo. Aromatic compounds, it's an aromatic benzene ring is the parent for all aromatic compounds. So any compound that has a benzene ring, which is like a conjugated system, you have double bond, single bond, double bond, single bond, double bond, single bond, is going to name aromatic. And it could be branch or simple. So you could have like a methyl group here, methyl benzene, or it could be just the benzene ring and is aromatic. They have, if you have methyl benzene, the other name for it is a toluene, and dimethyl benzene, they have xylene, and then this group with the benzene still is aromatic compound, like a styrene. So you have 1 chloro and 3 methyl. So you have 1, 2, 3. So it's going to be 1 chloro, 3 methyl benzene. 1 chloro 3 methyl benzene. It's just representation, that you don't have to write the carbon and hydrogen. It's like if you have this corner, that means you have the carbon. So that's the end of the hydrocarbons. The rest of the families, they have either oxygen containing or they are nitrogen containing. Your alcohols, they have oxygen containings and ethers. And then amines and amides, they are nitrogen containing compounds. To try not to make the videos too long, I'm going to stop here and then record the rest of it in a new video.